Okay, so first things first. Hey, guys. I'm going to go ahead and just download the notes. Okay. And then we'll go ahead and get started. So I'm going to open these Notability. Create a new note. Cool. I'll file those later. And then in Notability, yep, say hi to Pa and Frida because they. Okay. There it is, right on top. So today you should have already completed the introduction and the discussion. And I am going to assign the 7-1 section. So you can go ahead and put today's date, let's see, 6/4/8 down as the assigned date for these two. Now, the first one is a Google form, which I know we haven't done a lot of, but it will walk you through and it'll tell you if you're wrong during every stage, right? So that you can get through a whole problem correctly, and it'll give you hints if you're getting stuff wrong. So it's meant to be like an extra teaching tool for these basics that I could do if I was there for you, but I can't do because we're online. Okay, so do that even though all that is going to show up is that you viewed it to me. It's beneficial. It will help you get these other 4 correct much easier. Whoa, that's a tiny highlighter. Cool. Yeah, so those 2 things. Okay, so with that being said, let's go ahead and look at the 7-1 notes. Okay, so we're going to look at trigonometry in this unit. So trigonometry, where does the word come from? Okay, so trigon is Greek for triangle. Triangle, makes sense. And metric, it's like measuring things, right? So it's all about measuring triangles. So triangles have 3 angles and 3 sides. And trigonometry is all about using shortcuts to find missing things that you might need to know using minimal amounts of information. Okay, so kind of like we did shortcuts in our triangle congruence unit, we're going to use trig as a shortcut now. Okay. Remember that the 2 sides of a right triangle which form the right angle are called the legs. So these are the legs. And the 3rd side opposite the right angle is the hypotenuse. Okay. We're going to start with the tangent ratio. Okay. The tangent ratio compares the measure of the leg opposite an angle with the measures of the leg adjacent to that angle. Okay. The symbol for the tangent of angle A is just tan A. Okay. You've probably seen these on calculators before. It's those 3 little words, right? Tan, cos, and sin. It's actually tangent, cosine, and sine. So we're finally going to learn how to use this. Okay. Remembering that adjacent means next to. Okay. So I'm going to find the tangent of A and the tangent of B for each of these triangles. Okay. This will make more sense when we get into the applications of this next, but for now, learning basics. Okay. So find the tangent of A and tangent of B. So tangent is opposite, compares opposite to adjacent. So what that means is the tangent of angle A, the side that is opposite A is this 45. Okay. The side, oh my God. The side adjacent to A, so next to, is going to be the 28 because 53 is the hypotenuse, so that's always its own thing. Okay, so that ratio, opposite over adjacent, opposite to adjacent, is 45 over 28. Okay, so same thing. I'm going to pick a different color so that it makes sense. Tangent of B. Now this is where all like perspective matters, because what was opposite to A is now actually adjacent to B. So our opposite is the 28, and the adjacent, or the one next to angle B, is the 45. So this one is now 28 over 45. Okay, so depending on the angle we're looking at, the trig ratio is different. Okay, so same thing with this one. And I'll just continue on with my little pattern here. Tangent A, and you can get a little bit shorter. So opposite O, adjacent A. I like to label them all the time until I really get a handle on it. So that would be 56 over 33. And the tangent of B, opposite is 33 and adjacent is 56. So you notice that these are always just flipped upside down. These are inverses of each other, okay? Or reciprocals. Okay, I'll leave 3 for you to try on your own. Okay. Sine ratio, same thing, except that for a right triangle, it's the opposite side length divided by the hypotenuse length. So I'm just gonna opposite divided by the hypotenuse. Okay. You looked at these in your exploration, so we're just doing some extra practice here, formalized with some video support. Okay, so sine of R and sine of S. Again, I'm just going to do one, and then I'll let you do the other. So sine of angle R. Now we're talking opposite over hypotenuse. Okay, so the opposite is 24, and hypotenuse is 26. Okay. The sine of angle S. Opposite is the 10, and hypotenuse always is the same because it's that longest side, is 26. Oops, 10, not 0. Okay, I'm going to leave B for you to do on your own. You can pause this video as much as you need to. Cosine. For a right triangle, the adjacent side length divided by the hypotenuse length. So I'm just going to fill that in quick. Okay. Same thing, so I'm going to put a little key here so I remember what I'm doing. Adjacent hypotenuse. So first things first, cosine of A. So the cosine A is adjacent, so the 14 is next to it, and the 50 is the hypotenuse. So 14 over 50. You have opportunities to reduce these and all kinds of things. Unless it asks you to do it, don't bother. And the cosine of angle B. Again, the adjacent now is in a different spot because perspective matters. So the cosine of angle B is 48 over 50. Okay, I'll leave B for you to do as well. So in order to remember these, because how else are you going to remember? We use the word SOHCAHTOA. Okay, so you can kind of see it here. Most often it's written like this just because it's easy to type, but I actually really like to write it like this. So if you also do, that's okay. So I like to write it like SOHCAHTOA. And you can see in here the ratios and how they're already kind of made when you write it like this. Okay? Try saying that out loud, SOHCAHTOA, so that you doesn't sound weird later. I don't, whatever. Say the word. Something else to be aware of is that angles can be measured two ways. We've only talked about degrees, and we're going to continue to only talk about degrees in geometry. But radians exist, and sometimes calculators like to be in radians. So if you're in a calculator, go to mode, whatever that looks like, and just make sure that degrees is highlighted. So like on our classroom calculators, it would look like this, and there's actually gradients as well. So degrees is highlighted. But if not, I could just go over and say, oh, it's radians is highlighted, and get it done. I did put a link to the MCA calculator on Schoology. It should be like the second item below the calendar. For like that type of a calculator, because the keystrokes need to be in a different order, but I will have instructions for you on that later. Okay. I'm going to pause this video, and there's 2 more examples, and you can watch that video after this.